0. Okay? So then I have x equals 3 and 2/3. Riddle me this. If this side is 3, and I cut out a 3 by 3 square from both sides, I have a negative volume. It just doesn't work. Okay, so does that make sense that the 3 doesn't make any sense? So I'm only going to use this one. Yes, Josh?
Could you also technically just plug that into your
Yeah.
derivative to see if it's
We could do a number line test. And if we plug in, if I plug in 0, I have a positive. If I plug in 1, I have a negative. And if I plug in 5, I have a positive. So it's increasing, decreasing, increasing.
We want the min.
We don't want the min, we want the max.
Oh, the max. Right.
Yes. Yes. Also, let's just say you didn't want to do the number line test. Just plug in 3 and 2/3 separately into your original equation. Here, you'd get a negative number. Can you have a negative volume?
No.
That's called a black hole, right? Okay. So far, so good? You got it? The concept's making sense? You feeling better about this test? Yeah.
So you plugged the 3 into the original equation where you did the FOIL, and
You could.
it doesn't work because
It'll
it's
give
negative.
Yes. Okay, is everyone with me? Are you ready to go into, actually, I'm going to show you the rest of this problem. So there are two different ways that they ask the question. Sometimes they ask for how big the square is you cut out, in which case it's 2/3 and 2/3, right? 2/3 by 2/3, right? Or they ask for the volume. If they ask for the volume, what do? I just plug this into that, and I'm pretty sure it's 200 over 27. I did it lots of times. I did not just do that in my head, but I think that's what it is. Yeah? It's not super important. You understand what to do, right? You're giving me the blank looks.
I got it. Crystal clear.
Beautiful. Okay. Yeah. So now what I would like to do is one of the triangle problems. A triangle problem, and then I would like to do a concavity problem. Yes.
Oh, right. Are we going to do a fence problem?
If we have time. I hope we have time. I think we should have time. But I want to do a triangle problem. I want to do a concavity problem. I want to do 1 or 2 implicits. I want to do 1 easy implicit and 1 tangent line implicit. I'd like to do some sequences in series, and then 1 Taylor polynomial. Yeah.
So the way we tell if it's just one formula is 2 or 2 formulas is just if in the story it's saying one, or it only gives one thing, like that one only needs thing.
Yeah.
That one's really
Yep. Okay. Shall we? I think we need to go on a little bit quicker.
Yeah.
Can we move? Can you put the camera back on this side?
Yes.
Thanks. Okay. I want to do a triangle problem.
Oh, it's too zoomed.
I'm just going to make up a triangle problem, so it may or may not come out pretty. Is that okay?
All right.
Or do you want me to, yeah?
Sometime throughout tonight, could you talk a little bit more about like domain and just figuring out domains?
Cool.
Maybe towards the end.
I don't promise, but I will try.
Oh, cool.
Okay.
There's a triangle problem in the book.
There's lots of triangle problems in the book, but I want to give you one that I have a specific one I want to show you. This one. But I can't remember all the numbers. So here's the setup. Here's the guy's house. Not a very good house. Okay, here's a guy in a boat. This is water. Okay? Actually, I'm going to just put that there. I think that this is 6, and I think that this is like 15, something like that. I can't remember. I'm just trying to, this is not an exact problem I've seen on a test. It's just similar. The numbers are different. So, yeah, right? That's fair. axis. Okay, here's the deal. It's a really dumb question. In the water, he can row at, I think it's 2 miles per hour. And he can run at 5 miles per hour. And his house is on fire. And he's trying to get there as fast as possible.
I'm drawing the fire.
I think he should just call the fire department.
Should he hop out of his boat or just keep paddling on land?
The fact that he's quick. Is 5 miles an hour fast? It seems really, really slow.
For running,
Like walking?
Just do
Running
it.
fast walk.
He's really old.
Feeble.
You know, I'm gonna really guess 5 because at least it's a small number. I'm gonna show you how to. What? Okay, guys, we gotta go. You're right. You gotta go fast. Always put the X inside the triangle. Okay? Otherwise, you will hate your life. Next, what you do is this side plus this side squared, square root. And we're trying to get there in the least amount of time. Time equals distance over rate. So in this case, time equals our distance on the water over how fast he can go in the water, plus his distance on the land over how fast he goes on land. Yes?
You just got that from the algebraic equation, C equals square root of this miles per hour.
Yeah. Pythagorean theorem, indeed. Okay, I'm going to try not to fly too fast, but we got to fly or we're never going to get to everything.
You mean swim? Just kidding.
Yeah. I mean, swim, I know. Okay, we're just going to take the derivative of this, set it equal to 0, find our critical numbers, and then only one of them will make sense, and we'll use the one that makes sense. Okay? I'm just going to go. So, t prime is equal to 1/4 x squared plus 36 to the negative 1/2 times 2x plus 1/5 times negative 1. So, this is going to cancel with that to make it x over 2 square root x squared plus 36 minus 1 over 5 equals 0. Notice I have two fractions. One is 0. One is negative. Let's put the negative 1 on the other side. I'm trying to keep it really similar process for everything, so you can see how to do it. I'm going to cross multiply so I don't have any fractions left. 5x equals 2 square root x squared plus 36. Did I lose y'all? I know, we gotta go faster, we're not gonna get through everything. Okay, I'm gonna square both sides. We have 25x squared equals 4x squared plus 36. I'm gonna distribute by 4. No, it didn't come out. I should have made that a 3. 36, 4, 4, 16, 9, 3, 3, 144? Beautiful. Minus 4x squared. Minus 4x squared. 21x squared equals 144. Divided by 21. Am I going too fast?
No, you're good. Keep
Just
going.
laughing. X squared equals 144 over 21 square root x equals plus or minus 12 over the square root of 21, which doesn't come out nice. But do we want a negative?
No.
Can you have a negative distance? No. So x must equal, and then all you do for time, because they're going to want to know how soon he can reach it, is you put this into this. Oh, pretty. Plug your x into your time equation, and you'll get your time. Usually it comes out to be like 2.5 hours.
Into the original time.
I'm kind of thinking his house is gone.